The stationary fuel cell market is set to reach $8 billion by 2035, with solid oxide and proton exchange membrane fuel cells accounting for the greatest market share. But these two technologies operate in different ways, making them better suited to different applications. The PMFC market will primarily be driven by mobility applications and for backup power, due to their low operating temperature, allowing for rapid startup times and quick responses to power demand changes. The technology is, however, sensitive to carbon monoxide impurities, and so they can only operate using ultra-pure hydrogen. Their market growth is therefore highly dependent on the development of the hydrogen economy. Solid oxide fuel cells conversely operate at very high temperatures, meaning they can only be operated continuously due to very slow ramp-up times. However, this does allow for their operation using cheaper and more readily available alternative hydrogen carrier fuels. And so leveraging of their fuel flexibility will allow solid oxide fuel cells to establish early dominance in the stationary fuel cell market. Competing with solid oxide and proton exchange membrane fuel cells are alternative fuel cell technologies. This includes phosphoric acid, alkaline, molten carbonate, and direct methanol fuel cells. Molten carbonate fuel cells will dominate over the alternative technologies, as similarly to solid oxide fuel cells, their high temperature operation allows for fuel flexibility, and their use of carbon dioxide as a fuel provides a unique opportunity for the decarbonisation of industry. Phosphoric acid fuel cell growth is anticipated to tail off by the end of the decade, with major players in the sector beginning to transition into the development of proton exchange membrane or solid oxide fuel cell technologies. Both alkaline fuel cells and direct methanol fuel cells possess rapid startup times to allow for their use as backup power devices. However, direct methanol fuel cells typically possess lower power densities, and so their uptake will be restricted to much more niche use cases. Overall, these four alternative fuel cell technologies will account for around 10% of the total market demand by 2035. So where can we expect uptake of stationary fuel cells to be seen? Well, both the utilities and commercial sectors are set to account for the greatest share of fuel cell demand by 2035. For all of the five main sectors, however, fuel cells will be integrated for both backup and continuous power generation, with the data centre and telecoms market being dominated by backup power systems, as many companies are looking for the replacement of polluting traditional diesel generators with greener and renewable technologies. Overall, driving the uptake in fuel cell systems is the rise in global energy demands, along with concerns over energy security and an increase in decarbonisation goals. So for more information on the stationary fuel cell market and the application areas driving their uptake, please reach out to IDTechEx or visit us at idtechex.com/stationaryfc.